Hello and welcome to another one of these ADD videos. Today we're going to look at an example of Coulomb's law given point charges, and we're going to look at Q1 having this charge, Q2 having that charge, Q3 having this charge. Distance between 1 and 2 is 2 centimeters, 2 and 3 is 4 centimeters. And what we need to do is look at what the force is felt on Q2. So what we need to do at first is just kind of intuitively get a feel for where the force is going to be pushing Q2 or pulling Q2, whatever the case may be. So if we look at trying to set up a force diagram, what we should realize is that the force on 1, 2 is going to, here, let's zoom out a little bit, because 1 and 2 are the same charge, we're going to get a repulsion, so it's going to push that way. And 2 and 3 are opposite charges, so it's going to pull it also in that same direction. So actually I'm going to zoom back in. That's what that's doing right there. So 1, 2 is pulling that way, or pushing that way. 3, 2 is pulling that way, so F net is that way. So all we got to do is apply Coulomb's law. Remember, we've got force is proportional to the product of the charges and inversely proportional to the radius squared, or the distance between the charges squared, where K is this Coulomb's constant, where we have 1 over 4 pi constant permittivity, which gives you 8.99 times 10 to the 9th newtons meters squared over Coulomb squared. Easy way to remember the units for that K is that you need to cancel the meters out of the bottom squared and the Coulomb squared out of the top. So you got to have these two, and it's a force, so we need newtons. So that's how you can remember that one. So if you apply Coulomb's law to 1, 2, these are charges 1 and 2. Hopefully you've already done this. You're not just watching this, you're trying these problems, right? So this is the radius between 1 and 2. Remember, beginning zeros to the left of the first non-zero are insignificant, so that 2 is the only thing significant there. And here we've got 2 sig figs, 2 sig figs. That doesn't count, it's a constant. Only the given information counts. Use the smallest number of sig figs in your answer, or in your problem, when you're multiplying and divided in your answer. So therefore we have 1 sig fig. So we take this wonderful number and round it up to 3, because we just look at these two. The 9 tells us to move that to a 3. So then I decided to put it in units. That's a lot more reasonable for us to write. You don't have to do this if you don't want to, but if you convert it into micronewtons, we get 300 micronewtons. Same thing with Q2 and 3. If you do that, you'll get this wonderful number there, and then you'll round that 1.4 down to a 100 micronewtons. And then the net force is going to be that 300 plus 100 is 400 micronewtons. And as we said, it's going to be in the positive x direction. So that's a very basic example of how to use superposition and point charges to calculate the net charge or net force felt on an object. Notice that there was no dimensionality here. The next example, we will have x and y axis involved here. Alright, so make sure you check out that example video. Practice, practice, practice. After you do enough of these, you'll see that they're not too bad. Thank you and have a nice day.